Hello, welcome back. Today I'm going to explain how to find the area of the shaded portion when two squares are inscribed in each other. They're overlapping squares. Okay, let's begin. Two squares are each with side length 14 centimeters are placed so that the vertex of one lies in the center of the other. So this square, I'm just going to name this square 2. This is square 1. Square 2 corner is touching square 1's midpoint. And using that, we need to find the area of the shaded region. Okay. So let's solve the problem. We could break down the shaded portion into two triangles like this. But we only know the apothem or the height of the triangles using the side length of the square, but we don't know these lengths right here. So that wouldn't work. But then there's not really another way to do this problem. So that's where we need to dig deep into basic knowledge of math and look at the problem closely. Because these are squares, we know that all four corners are 90 degrees, like this. Yeah, like that. So because of that, we can use this rule. So let me draw it out in another side so you kind of get a better understanding. It's a little confusing. Here's the same diagram. They're both congruent squares, by the way. We know that this is 90 degrees right here. So let's assume the square was tilted a little bit to the left so that this line right here would be parallel to this line. And if it were tilted like that, the figure would look something like this. Two squares. And because the tip is touching the midpoint of the square, we could find out the area of this overlapping region by just finding 1/4 of the total area of this square. Because we know that's 14, we can just do 14 squared, which is not 2. Oops. It's 196. And we could easily just do 196 divided by 4, which is 49. But our shape looks a little different right here. So we would think that we can't use the same answer from that. But we can, because both of these figures are pretty similar. The only difference is that their overlapping section is a little shifted. This is the overlapping portion of this figure right here. And we can see that the only difference is these two lines have shifted in this figure. So what we can do is we know that both of these overlapping regions have 90-degree angles. It's a little hard to see, but they have 90-degree angles. And because they have 90-degree angles, we can say that this triangle and this triangle are both are congruent or the same. Because they both touch the same midpoint right here, and they're both the same degrees. They're only shifting a little bit to the right. So because we know that both squares are congruent, let me just draw those two shaded regions over here. I'm drawing them so they're overlapped. So it looks something like this red portion right here. We know that these two triangles are, so let me just color code that. This is similar, is these two are the same triangles. Those two have the same area. That's what I meant. And because they have the same area, we can just take this triangle right here that looks in the, like from right here, this triangle right here, and we can move it down here. And if we do move it there, the shaded region becomes a square. And if you recall, we were over here, we explained how to find the area of the shaded region if it was a square. And now that we know that the shaded region is this shaded region right here is equivalent to this shaded region here, our final answer is 49 square centimeters. I hope you understand how I did this. This is a really simple problem. You just need to dig deep into the basic fundamentals of math. Thank you for watching, and I hope you have a good rest of your day.